Hi, Andre. So we are recording live today at the beautiful Newport, Rhode Island, and we are at this 361 event. And we have all kinds of investors, founders here. And I'd like to ask you about your company and about your startup. I know that you're in biotech. What exactly are you doing? What problems are you solving for the world?
Thanks, Anna. It's great to be here. So, we work in gene therapy. For the most part, we work on how to target specific cell types and tissues for what we call the delivery problem, which is, in a way, it's a last mile, final frontier sort of problem in medicine. That we have all of these advanced understandings of what causes different diseases. Particularly, a great example would be the single gene defect monogenetic diseases, things like sickle cell disease, cystic fibrosis, beta thalassemia. There are more than 7,000, and they affect about 1 in 10 people, or about 8% of the U.S. population. Um, and in these cases, we know exactly what's driving the disease, and it's a very simple, clear-cut mutation that is driving it. And yet, even with the most advanced genetic engineering tools, things like CRISPR, mRNA therapies, all this stuff, we can't address most of these diseases. So it's not anything to do with the conceptual understanding or the diagnostic information. It's everything to do with, can you actually deliver the cargo that could edit the genome or correct the disease state to the appropriate tissues. So my company is called Ligandle because we make what we call ligands, or they're basically molecules that target specific cell types, and then we latch them onto these nanoscale delivery systems, kind of like when you go get a Moderna vaccine or a Pfizer vaccine, you're getting mRNA technology in a nanoparticle. We're giving those particles the specificity and targeting, like the molecular GPS or the FedEx of the nanoscale molecular delivery world. So
Thank you so much. This is fascinating. You're solving huge problems for the world. Do I understand correctly that at some point we'll be able to modify the gene and then the diseases will disappear? And that's the question number one. And question number two, are there actually any success cases in your area, maybe in sickle cell or any other diseases that have been successful?
yeah, for sure. So as I mentioned, I think with the monogenetic single gene defect diseases, these are going to be some of the first ones that we see efficacy for. And these are typically rare diseases as well. So they might have smaller patient populations, but in the US, anything less than 200,000 patients is considered a rare disease. So sickle cell is a great example. So is beta thalassemia. There have actually been some positive data sets recently generated by CRISPR Therapeutics for sickle cell disease, and then Bluebird Bio for beta thalassemia and sickle cell, though they ran into some problems with their sickle cell study. So you can think of this as the first generation of these technologies being what we call ex vivo. So cell therapies, you have to take the cells out of the body and put them back in. Intellia Therapeutics, with their CRISPR delivery, they were able to deliver CRISPR into the liver to treat a specific disease state. This is not a cell therapy. This is a direct injection, which is really cool. So I think as we expand the organ targets and start off in these rare diseases, you'll then see an expansion very rapidly into other more complex disease states that might also require multiple things to be delivered. So that's kind of where we're at today as a field. There are a lot of viral gene therapies, so other ways of delivering things include viruses, but there are a lot of issues with toxicity, immunogenicity, your immune system learning what the virus looks like, so you can't do a second dose, and also the persistence of the gene in those cases. So I'm really bullish on gene editing, but also on more temporary deliveries where you might produce something for a couple of weeks for a regenerative medicine purpose or whatnot. But these things could take 20 years to see their full maturity, or longer even, in terms of really being able to go to the doctor and say, hey, something's going to be wrong with me, or I'm getting older in this way, in this way, in this way, and actually going in and addressing that. So you'll see that for decades to come. It's still being developed.
Thank you so much for this. And finally, can you tell us the name of your startup and also the funding stage that you're at, if you are raising any capital, and also who are your investors, and maybe a little bit about your background, how you came to this field?
So the company is called Ligandel, which is, as I mentioned, named after a ligand, so a molecule that sticks to another molecule. We've raised about $9 million to date, so we're pre-Series A. We're getting another $3 million or so in. We'll be raising a larger round next year. So we have a laboratory in the Brooklyn Navy Yard that we just moved to. We're building out a new manufacturing space. It's very exciting. So that's going to be the next couple of years, just building out that infrastructure, getting that to the next stage, and hopefully getting into some clinical trials in the next 2 to 3 years would be the goal. In terms of my background, I'm a biomedical engineer. My focus has been on biomaterials, nanomaterials, and really drug delivery as applies to gene delivery. So I graduated from Rensselaer Polytechnic Institute back in 2013. I've been building the company ever since. Thank you, Anna.
Thank you so much for this. Very nice to meet you.
Pleasure
Thank you
to
for
meet
your
you.
interview. Thank you.
Come join our 361 firm community of investors and thought leaders. We have a lot of events created by the community as we collaborate on investments and philanthropic interests. Join us.